for f of x greater than or equal to 0, which means we need the graph above x-axis. F of x less than 0, which means below x-axis. For coordinate plane, this part means f of x greater than equal to 0. And for this part, this means f of x less than 0. For f of x equals a, in what situation we have two solutions, one solution and no solution. Suppose this is a y equals a. The first quadratic function, we have two solutions. Because the line crosses the graph of a quadratic function twice. The second quadratic function has one solution because the graph of a quadratic function intersect y equals a once. For third quadratic function, no solution because y equals a and the graph of a quadratic function has no intersection. Let's go to f of x greater than equal to 0, which means above x-axis. So which part is above x-axis is this line and this part. So you could say the x-axis, it will be this part. That means x less than equals to 2. For over here, this is x greater than equal to 3. So let's write down x greater than equals to 2 or x greater than equal to 3. We can use negative infinity to 2. Unit set from 3 to positive infinity. For second graph, f of x greater than 0 will be all the graph here. And for x-axis, it will be from here to here. For all x in x-axis, we can label this part is negative infinity, positive infinity. So it will be from negative infinity to positive infinity. Or you can write down x is all real numbers. For third graph, there's no graph above x-axis. So you can write down empty set, which means that nowhere the graph is above x-axis. For f of x less than 0, which means below x-axis. So from here to here, this part, it will be x greater than equals to 2 and less than equals to 3. Or you can use this way to show interval. For second graph, there's no graph is below x-axis, so this is an empty set. For third graph, f of x less than 0 means below x-axis. You could see all the graph is below x-axis. Therefore, you can write down from negative infinity to positive infinity, or x is all real numbers. For f of x equals to a, in what situation has two solutions? Let's go to f of x equals to a has two solutions. We know this is a minimum point. When you draw a line, it's above this minimum point, like this. When you draw a line, it's above this minimum point, and you will cross this quadratic function twice. If you draw a line, it's below this minimum point. You could say there's no intersection. If you draw a line exactly across this minimum point, then you could say the graph will intersect this line only once. Therefore, while you solve this is a two solution, one solution, and a no solution, you will focus on the vertex or minimum value when this a greater than negative 0.5 has two solutions. When a less than negative 0.5 or no solutions. When a equals negative 0.5 or only one solution. Same thing to the second graph. This is a minimum point, 5 or 0. When a greater than 0, two solutions. A less than 0, no solution. A equals to 0 has one solution. This time, if I draw a graph below this maximum point, then has two intersections, which means two solutions. If I draw the line is above this maximum point, which means no intersection, no solution. I draw a line exactly passing through this maximum point, which means one solution. When a less than negative 4.875, two solutions because there are two intersections. When a greater than negative 4.875 or no solutions. When a equals negative 4.875 or one solution.